So today we are going to be starting with module 3. Under dynamics, we are going to be looking at the laws of motion, the Newton's laws of motion. Chapter 3 is divided into 3 sections. The Newton laws of motion. We are going to be looking at kinematics, kinetic and potential energy, and the conservation of energy as well, and how to apply them. But the first aspect, we are going to be starting with what is dynamics. When we started with kinematics, I did say that there is a difference between kinematics and dynamics. So with dynamics, dynamics is a study and the study or the science of forces that causes motion. Now, the entire system of dynamics is based on these 3 laws. This Newton's 3 law of motion. We're going to be looking at that and how do we apply them. There is a formula that is actually attached to those laws. So this law describes the relationship between the motion of an object and the forces that is causing it. The reflection is too much. We can switch off the light. So with dynamics, we have some terminologies that need to be known, like the mass, the weight, the momentum, and the inertia. So of course, with the mass of a matter, this mass is a matter that is contained in a body in kilogram, and then we have the weight. The weight is the force by which a body is attracted to the center of the head. So with the weight, of course, is going to be the mass of the body multiplied by the gravity, which is 9.81 meters per second squared. And then another very important terminology here is the momentum. So the momentum is the quantity of motion possessed by a body. So with momentum is mass multiplied by velocity. So when we are talking about change in momentum is going to be mv minus what? Minus mu. So v being the final velocity and u being the initial velocity. And also another terminology here is the inertial. So the inertia is an inherent property of a body that offers resistance to change in motion. I think I did discuss about this a bit. I think it was yesterday I was mentioning about I was talking about inertia when we were looking at accelerating torque. Like I said, it's inertia multiplied by the angular acceleration. So so these are the terminologies that we need to know under this aspect. So with the Newton's first law of motion, you might be asked to state the laws of motion, either the first law, the second law, and the third law. So with the first law, it states that a body will continue in a state of rest or uniform motion or uniform acceleration unless acted upon by an external force. And at this point here, um, you can see that there is a picture that I put here as well, just to describe the fact that a body that is uh, just moving in a uniform motion or at rest. You can see this picture actually describes Newton's first law of motion. So you can see an object at rest. This is the force that is acting on this object to make it exhibit a motion. So with the second law of motion, it is also referred to as a law of momentum. So this states that the change in momentum of a moving object is directly proportional to the magnitude of the force that is producing the movement in the same direction. So with momentum, momentum has to do with motion. Like you might have been hearing from the word when something gain momentum. So of course, with momentum, there is a force that is producing that will cause the momentum to change. So the momentum will actually change from initial to final. So with the change in momentum, this is the formula right here. The change in momentum of a moving object is proportional to the magnitude of the force producing it. So the formula for calculating momentum is mass times velocity. So the change in momentum is going to be mv minus mu. So the rate of change of momentum. So with the rate of change, we are going to be referring to the change of momentum per unit time. So the formula can be transformed into mv minus u over t, of course, with our mass change in velocity over time is acceleration. So the rate of change of momentum is can also be referred to as the accelerating force, which is mass times acceleration. So the law states that the applied force is proportional to what? To the mass multiplied by the acceleration. So this is the formula for the second law, Newton's second law of motion. If you apply more force to an object, it accelerates at a higher rate. So you can see that there is a mass here. On this picture, we have a mass, and then we have a force, which is the pushing force that is attached, trying to push the mass to increase the speed. So this is just an illustration of the second law. So the third law, which is the easiest law, is a law of action and reaction. It states that for every action, there is an equal and opposite reaction. So in other words, you can see that if an object A exerts a force on another object, the object B will exert an equal and opposite force or reaction on object A. So this is just like a practical example. So this one is the easiest out of the law. So let me just take out this, the law of action and reaction. So this is where the work is. Force analysis of a moving object. So we are going to be looking at force analysis of a moving object on an horizontal plane, and we are also going to be looking at the force analysis of a moving object on an inclined plane. The inclined plane is when the plane is inclined at an angle. So if an object of a mass moves at a uniform velocity or acceleration, we apply the second law of motion. So most of our calculations is going to be based on the Newton's second law of motion. So I want you to look at this. I want you to look at this diagram here. Now we have a mass here that is on a sliding motion. And then we have the force here. The force here is the applied force. Now, this object will be able to move forward if the applied force here is greater than. Now, this formula here, I will call this frictional force or resistance force. So if the applied force is greater than the frictional force, of course, the frictional force is the force that will oppose the movement of the motion. The object will move forward. Object will move forward. That is if the applied force is greater. But if the frictional force here is more than the applied force, now the object will still be stationary. So that is the concept of a sliding motion. And then you can easily generate a formula from this concept of motion, that the force that will cause the motion to accelerate, that will cause the body to accelerate, is going to be the applied force minus the frictional force. The applied force minus the frictional force is going to be equals to what? Mass times acceleration. So the force that will cause this body to move is the accelerating force. Of course, with the accelerating force, it has to be uh, the applied force minus the frictional force, because the frictional force is lesser than the what? Than the applied force. So you can see here, this is the applied force, can also be represented by F or FA. This is the frictional force, and this is a normal formula. From the concept of friction, we know that when we have a body that is moving on an horizontal plane, of course, we have the force that is causing the movement. We are going to have an opposing force, which is a frictional force. And then this body has a mass, it has a weight, and of course, there would be a reaction. For every action, there is a reaction. So we can easily um, deduce that the accelerating force equals to the what? The frictional force is equals to the coefficient of friction between the body and the surface multiplied by the weight. This can also be written as coefficient of friction multiplied by the reaction. The weight is the action and R is the reaction. So the weight and the reaction is taken to be the same. So the weight is the same thing as the reaction. So this is where the concept is coming from. The reason why um, I wrote this force causing the acceleration to be equals to the frictional force is because from the force analysis, of course, here the accelerating force has to be greater than the frictional force. So because the force is opposing each other, you can actually write this as Fa minus what? The frictional force. But the concept of what we want to derive here is the formula for the force that will cause the object motion to move forward. So this is from the concept of friction, is what is also applied here as well. So with the accelerating force or the unbalanced force, we can say that the unbalanced force is the applied force minus the frictional force. The unbalanced force is the force that will cause the body to accelerate. And remember that if you want to determine the accelerating force, is mass multiplied by acceleration, which is ma, which is a normal formula. So that's the reason why it's equals to ma. So the whole concept is actually derived from the concept of friction here that I described here. So the same thing happens to when you have an object. This is a rolling motion. This one is not actually sliding. This one is the sliding motion, and this one is a rolling motion. So the formula still remains the same. So this is the coefficient of friction between the roller and the surface. Was that to be given? Okay. The next concept here that I want us to describe here is the concept of the movement of a body up an inclined plane. So there are some formulas that I put inside the red box. Those formulas are very important. Um, if the movement is upwards, if the movement is upwards, now I want you to look at this diagram very well. So because it's an inclined, it's going up an inclined plane. So we have there is a component of the weight that is parallel to the inclined plane, which is W sine theta, and then we have the other component which is W cos theta. But according to this calculation, we are going to be using the component of the weight that is parallel to the inclined plane, because we are actually considering the motion of the body um, on that plane. Okay, how is this formula derived? I just want to show you something here. Okay, if you look at this, if you look at this concept here, the direction of the motion is upwards, right? Now it simply means that we have a force which is F that is facing a direction, and then we have the frictional force, the sum of the frictional force plus the component of the weight that is parallel to the inclined plane facing the other direction. So if I want to do a force analysis here, I will say that for the upward movement, I will say that F is going to be equals to the coefficient of friction plus W what? W sine theta. And because the acceleration is upwards, I can say that it's going to be the applied force minus coefficient of friction minus the component of the weight that is parallel to the inclined plane is going to be equals to mass times acceleration. Of course, that's the accelerating force that will cause the object to move upwards. So that is where this formula is being derived from. So it simply means that the applied force there for that object to move upwards, the applied force here has to be greater than the sum of the frictional force and the component of the weight that is parallel to the incline. So the component of the weight that is parallel to the incline is always acting downwards. It's always acting downwards. So this is the first equation here. This is for upward movement. For downward movement, you can see that the applied force direction has changed here. But then the component of the weight that is parallel to the incline still remains the same direction, still facing down. So you can see that the equation is different. This is minus, in this case is positive. Because if I want to analyze the force in this system, I will say that the coefficient of friction is equals to the applied force plus what? W sine theta, because both are facing the same direction. So that I can easily say that my applied force minus the frictional force plus W sine theta is equals to mass times acceleration. So this is the first formula for upward movement. This is the second formula for downward movement. So what is important here is the formula that I put in the red box. So you can just write this down, and for the upward movement, you can write this down for the downward movement. So that is how the concept is. So now let's see how this is being applied in a practical problem. Those online, I hope you guys are following us. Okay, let's look at some activities here. First, let's start from the easiest one. Activity 3.1. I think the question is the same as the one in the old textbook. Okay, let's look at this question. So the question says that a car is moving at a velocity of 90 kilometers per hour. 90 kilometers per hour on a what? Horizontal road, not incline now. As I said, the brakes are applied and the car comes to rest after. So it simply means that this is like the initial velocity. Then it comes to rest after a distance. So the final is what? Is going to be 0 kilometers per hour. After it has moved a distance of 60 meters. 60 meters. Mass of the car is given to be 900 kilogram. I think with this one, we're not going to do much calculation. So the first question there is for us to determine the deceleration. With the deceleration, I think we can use this formula v squared minus u squared divided by what? 2s. So the final velocity being 0 there, they said the car came to rest. So it's going to be 0 squared minus what? We need to convert this 90 to meters per second. It's going to be times 1000 divided by 3600 squared divided by 2 times the distance. Distance is what? 60. But if the first thing you can do here is just to convert it first. This 90, just convert it separately, and then you can now substitute it. Can someone give me the answer? Because it is deceleration, you are surely going to get a negative answer. This deceleration is going to be minus 25 meters per second. So what would be the deceleration of the car? 208. Thank you. Meters per second square. The braking force. The braking force. Guys, sometimes I might be using the another slide, so you have to refer to the textbook to read the questions. How would you determine the braking force? It's F equals ma, because with accelerating force and braking force, of course, the formula is the same. Accelerating force equals to the braking force is mass multiplied by, well, there is no symbol that is used in representing deceleration. So it's still A as acceleration. There's a symbol that is used in representing deceleration. We'll have just written it there. So it's just MA, acceleration. It's not accelerating, it's decelerating. So it's going to be the mass. I think the mass is 900 kilograms. So it's going to be 900 multiplied by the deceleration, which is what? You're not going to write the minus, you are going to use the absolute value, which is 5 point what? Maybe 5.21 or 208. It's going to give you what? 4687.2 newtons. Time taken to bring the car to rest. The car is decelerating from 90 kilometers per hour to 0. So with the time taken, we know that the acceleration is change in velocity per unit time. So we can say that our time is going to be equals to change in velocity over acceleration. So the change in velocity is what? Is 25 meters per second. The acceleration or the deceleration there is 5. I can use 5.21. This is what I was explaining. I think it was yesterday as well that I said you can't really get an exact answer. Someone here might write this answer as minus 5.21, not 5.208. So these are the things that would make the answer to be different, but the answer will still be correct. So this will give us what? 4.8. So this is going to be 4.8 meters per second square. Oh, seconds. We're seeing acceleration here. 4 point what? 4.8 seconds. Let's look at another question. Let's look at this together. So this question says that a track is moving on a straight line. So this one is still on the concept of horizontal plane. 120 kilometers per hour. So we can just convert this to meters per second. Times 1000 divided by 3600. on an horizontal road. It is brought to rest. Time given is what? 15 seconds. By a braking force. Braking force given is what? 20 what? Kilonewton. So the question says that we must determine the mass of the truck. Any idea? We have the velocity, we have the time, and then we have the braking force. We have to determine the mass of the truck. Can we first convert this to meters per second? Anyone? 120, 33.33 meters per second. So how do we determine the mass of the truck? How do we determine the mass of the truck? The braking force is mass of the truck multiplied by acceleration or deceleration. So we can calculate the mass of the truck here to be equals to the braking force divided by the acceleration. So we can use this formula since we have the braking force to be 20,000. Now we can determine the acceleration from the velocity and the time. So acceleration is equals to velocity over time. Velocity is 33.33. It took what? 15 seconds. Someone give me the value of the acceleration. 2.22 meters per second square. So you just substitute that. The braking force is 20 kilonewtons. This is going to be 20,000 divided by 2.22. From here, you'll be able to get the mass. 9,000.9. Okay. Kilogram. Some of these weird answers. 9,001 kilograms. Okay, and that is 5 marks. Not much calculation there. Let's look at question 3. A man with a mass of 90 kilograms. I think I've seen this question before in one of the past question papers. Lift. A man with a mass of 90 kilogram is in a lift. Mass is 90 kilogram. Calculate the force exerted by the man on the floor of the lift when it accelerates downward and upward. Let's do some sketching here. Let's assume this is the lift. This is the mass. This is the weight of the man. And you know that for every action there is a reaction. Say you have a reaction here, it is F. Now for the first one here, for the first question, they said when it accelerates downwards. So for downward acceleration, for the first one here, I would say that for this lift to go downward, the weight must be more than the reaction, which is the force. So I can easily say that the weight minus the force equals to ma, because it's accelerating downward. And accelerating force is mass times acceleration. So I can write this as W minus F equals to mass times acceleration. So with the force that is exerted by the man, so I can rewrite this expression as W minus ma equals to F. So this is the value that we are actually looking for. F is going to be equals to the weight minus mass times acceleration. So we can write this as mg minus what? Minus ma. So the equation will now become mg minus a. So for the downward movement, force exerted is going to be equals to the mass, which is 90. Then we have 9.81 minus 0.4. Can someone give me the answer here? 846.9. So this is going to be the force exerted by the man on the floor of the lift when the acceleration is downward. So what if it's upwards? With the upward movement, which is the B part, we're going to sketch that diagram again. So with the upward movement, this is the weight, this is the CG, and then we have the force exerted. So in this case here, we're able to deduce that for the downward movement, the weight must be more than the force, the reaction. So with this one, it means that the force must be greater than the weight. So you can write this as F. No, either way, we are going to be using 9.81 meters per second, whether it is upward or downward. No, yeah, you use it as 9.81, regardless of the direction. F minus mg equals to ma. So with this one, the force exerted is going to be ma plus what? Plus mg. So we can write this as ma plus what? Plus g. The mass given to us is 90 kilograms. It's going to be 90. It's going to be, the acceleration is 0.5. They said 0.5 downward. So it's going to be 0.5 plus what? 9.81. So the force exerted will be what? 927.9. Guys, you can try this question here, question 4. It's just 6 marks. You say you got what? 4.167. This is rolling resistance to motion. That is, let's assume this is a direction of motion. We have that opposing 600 Newton, and then we are to determine the braking force. What did you get as your braking force? So you can write and you can generate an equation here. Braking force plus 600 equals to ma. So that you can have your braking force equals to the mass there is 2,000 acceleration there is 4.167 MA minus 600. This is how you did it, right? You got 77734 newtons. So with the braking force, we make use of the deceleration that we got here. Okay, let's look at another question so as to gain more understanding. I want you guys to look at question 5. This one is an incline. I want to ask you guys a question. When you are given an incline in this ratio, what does it mean? But what does it mean? 1:40. Do you know what it means? In 2.22. I want you to take note that the second question here, you are asked to determine this force applied. The resultant force is the force that will cause the motion. You subtract F, the applied force, from the component of the weight. It's going to be the applied force minus W sine theta. That's the resultant force. I'm just giving you a clue. Anyone, how are we going to get the acceleration of the car? Can get that change in velocity v minus u over what? Over t. So it's going to be 22 point what? 22 minus 0. The time is what? 90. So this is how we are going to get the acceleration. With the total force applied, we are going to use, there is an equation I showed you here for upward movement. We are going to use this equation. So the force applied is that F there because the movement is upwards. 0.25 meters per second squared. Total force applied. Let me do this. Let me crop out that diagram. So the B part says that you must determine the total force applied. So I can write this as F FA minus the weight is mg, right? We've not calculated that. Can someone give me the value of the weight? 900 times 9.81. I'm gonna give you what? 8829 newtons. So this is going to be 8829. We are going to replace sine theta with 1 over 40, right? Is it 1 over 40 or 1 over 4? 1 over 40 equals to the mass is 900 multiplied by the acceleration, which is what? 0.0.25. It's something I want to show you here in this incline. I just want to clarify something here. That 1 in 40, it means that horizontal movement of 40, it will have gone what? 1. So if we want to determine theta there, we were going to use what? Tan, right? Which is going to be what? 1 over 40. I want someone to give me the value of arctan of 1 over 40. Arctan of 1 over 40 is what? 1.43. 1.43. What is sine 1.43? It will give you what? Okay. We can also do it in this way. What is 1 over 40? And you see that it's the same thing. That's why we represented sine theta by 1 over 40. You see what I did there? So when you are given an incline, maybe it's 1:50 or 1:20 or 1:30, you just replace the sine of theta by 1 over 40. Because sine of that angle is going to give you that ratio, which is 1 over 40. See? So that's the reason why we replace it by 1 over 40 in the sine. So I'm just going to clean this. So what's total force applied? We just need to simplify this. We divide 8829 by 40, and then we subtract 900 times 0.25 minus what you get. So what's going to be the applied force when you compute it in this way because of time? Maybe you can punch the calculator again. 445 point what? 725. Let's say 0.73 Newton. That's the answer. The last part there is the resultant force. The resultant force is I would say that the resultant force is the effective force, the force that will cause the mass to move up the incline. That is the resultant force. I can easily say that the resultant force is the same as the accelerating force, the resultant force. So we have the applied force, and then we have the component of the weight parallel to the incline plane that will try to drag the weight down. So the resultant force, because the motion is upwards, so the resultant force now is you have to subtract the applied force from W sine theta. Because W sine theta 2 is also a force that is trying to oppose the motion. So like what I said, can say that the resultant force is the same thing as the accelerating force. Let me just write that here. Resultant force, which is as well referred to as the unbalanced force, is the same thing as the accelerating force, which is equals to mass multiplied by acceleration. Accelerating force is ma, right? So you can easily say that your resultant force is mass times acceleration. So the question says that you determine the resultant force. So with the resultant force, you can actually solve this in two ways. You can use this equation here to get the resultant force, or you can use this as well to get the resultant force. So with the resultant force, I want you to use this equation, and then I also want you to use this equation, just mass times acceleration. This one is easy. Mass is 900, acceleration is 0.25. This will give us what? 900 times 0.25 will give us what? 225. 225 newtons. I want you to use this equation here. The resultant force, you subtract the applied force from W sine theta. Let's see what you're going to get. Pabalo, use this formula to determine the resultant force. The applied force minus W sine theta, it must be equals to 225. Is that what you got? As I say. So that proves the fact that the resultant force is the accelerating force or the unbalanced force. Who doesn't understand what I did there? It's clear, right? Still is what I used here to calculate. From here, I use this. So this is where we are going to stop today. You can practice the rest of the question to gain more understanding. So we'll continue from here tomorrow. Any questions?